Right, hello viewers. I did go over this in another video, partially anyway, but I thought we'd just go over some more basic stuff of it. Because I did touch on one of them. I touched on the series bit in the EMF, and we were talking about that, which kind of helped us to understand it. But as I said, you can never have too much help. Now, yeah, okay. So what we're going to be doing today, we're going to be doing about the resistance of series and parallel circuits. So, we've already done about a series circuit in another video, but I'll just go over it. So you've got your actually put the battery in the middle there. You got your battery. Sorry, good battery. Major bits are there of it. And we've got R. Call that R1. Now there is something called internal resistance, but we'll cover that in another video, which is donated by small r. I'll just call this R2. And I'm only going to put 2 resistors. You could have as many as you need, but I'm just going to put 2. Now it's not powering anything, because I'm going to keep it nice and simple for you, so you understand where I've got the values from and you're not looking at a light bulb when you don't need to be. Okay, so it may ask you like, well, what is the sum of the potential differences? So it might give you this thing here, and it might say, oh well, R1 is 3 ohms and R2 is 6 ohms. And it goes, calculate the total, oh wait, no, sorry, not ohms, that's something else we're going to do in a minute, because 3 volts, 6 volts, and it goes, calculate the sum of the potential, some of the potential differences in this circuit, and it's very simple, you just add them up. So V equals V1 plus V2, and what we can denote from that is, as we know, V equals IR, and the current doesn't change throughout the circuit as it's in a series. It does in a parallel, but we'll come on to that in a minute. So the only thing that's going to change is the resistance. So V equals V1, which is V1 equals IR1. So IR1 plus, just change the number of the resistor to the second one, so IR2. Now that's very good, but why have we done that? Well, it's to show you how to calculate the resistance in a circuit and how simple this is as well. So say, and this is for future reference, yeah, so we've got, actually I should have, it doesn't matter. So let's see, we've got, 2 ohm resistor in R2 at 6 volts. Obviously these are not accurate measurements, they're just given that I'm making up now. Give that 4 ohms. And it says calculate the total resistance in the circuit. And now we could do this a very easy way of just simply adding them up, but you're going to need, if it's a few marker, like 6 marker, no, it's probably going to be a 4 marker. If it's a 4 marker, you're going to need to show some working out instead of just putting a few notes down. So as we know, V equals IR, so R is going to equal V over I. We've got some of the potential differences. Now I'm not putting any values in, just so you get an idea of where we're going. So as R is V over I, V over I, well that's V equals IR1. Now all I'm doing is simply substituting them in. That's 2 over I. And these i's cancel out. So it's equal to R1 plus R2. And obviously you can substitute them into other equations that you might want to use, especially EMF, which is one we'll talk about in another video. So hopefully that's grasped your intention and your excitement into this topic. What we're going to do now is we're going to go on to the next exciting bit of the electricity with my exciting dull voice, which is the series bit, parallel. So let's draw the same sort of circuit, and then instead of putting the R in one place, put it in two parallel places, R2. So that's our circuit. And I may ask you, what's the combined resistance of this area here, R1 plus R2? And you can't simply add them up because they have the same potential difference. It's just one of the reasons. Anyway, so as we know, potential difference is going to be the same. So if we want to work out the resistance, V is IR. Now we don't have to work out V because they're the same, so we can go straight into finding out I equals V over R. So we don't need to start with trying to work out the potential difference because they're the same, and generally these are not given. So I is V over R, so I equals V over R1 plus V over R2. And we can put V over R into as I back into the start of the equation of what it equals. So V over R equals V over R1 plus V over R2. Now, you may notice that we've got a common, I'm going to call it the easy term, common top number of V. Now, obviously, as I said, V is going to be the same for both, so we can just assume that it's 1, so we can easily work this out. So 1 over R equals 1 over R1, so it should be an R, plus 1 over R2. And obviously you can sort it out, but what you try to work out is that R that I've underlined there. So hopefully you're starting to see that there. Yeah, I don't think there's much more we can do on the series there. He might ask you to calculate the total resistance when you've got a series and a parallel resistors, sort of like you've got one on its own and then two like that, which you just do the two separate equations, but that'd be probably worth a lot more marks, so obviously you're allowed to spend more time on it. So let's get rid of that. Hopefully you've understood that, as I said, and if you haven't, you can go back and obviously feel free to watch the rest of it again and again and again and again. So that's the main chunk of it done. See if there's anything I've missed. Right, okay, there's one thing I have missed there. See? Yeah. Yeah, okay. So, if we want to find the rate of heat transfer in a circuit, even, we know that power equals IV. I'm just going to put two equations that I'm going to use. Call that first one, call the second one V equals IR. Now you should be fairly familiar at this stage with them two equations. So we've got V equals IR, P equals IV. All we're going to do is substitute equation 1 into equation 2. So V into where it says V there. So when it's still power, that should be P equals I, brackets I times R. Expand this to get P equals I squared times R. And that is your rate of heat transfer. Now power on its own is not sufficient. You need to put the V equals IR into the equation there. Don't ask me why, but that's, if you know why that is, you could send us a link or whatever, and I'll definitely get it on the YouTube. Yeah, so that's basically it. just one thing that I want to go over. When you've got a series, you can add up the resistances and the potential differences, whereas you can't with a series circuit. And otherwise, pointing at a light bulb then and nothing on it. Yeah, so in a series circuit, the potential difference is the same, which could be helpful when you're calculating diodes and stuff with diodes. Again, anything I missed out, go back and watch the rest of the film. See you later, guys. Thanks for tuning in. And if you're watching future, well, hope this has helped you. And good luck. Do us proud, boy.